Continue where we left off. Um, to determine if a function is continuous, you basically have to apply your three um, your three criterion, and if it doesn't pass one of those, then you know it's not continuous. So in this example, where we left off, the last one was that you have to do first f of c is defined. So you have to plug into the function of c is defined, and in this case, it is defined. And then step 2 says that you have to check from the left-hand side and the right-hand side to see if they equal the same number. Well, the piecewise function is pretty easy to see that the left-hand side and the right-hand side are basically the functions that they give you. This right here will represent the left-hand side because the values that are less than 2 are the ones that are to the left of 2. So like 0, 1, -3, they're all to the left of 2. So you plug in 2 into x minus 1 and you get 1. And then the values that are to the right of 2 would be the function up here, because values to the right of 2 are like 2, 3, 4. So you plug it into this function and you end up getting 5. And because they don't equal each other, that basically know that criterion 2 is not met and there's a jump. And this right here is just a quick sketch of what this piecewise function looks like. And even though we haven't spent time on piecewise functions, and then like learning how to graph them and stuff, you're really gonna have to know algebraically how to do this. It's still there. So in this one, we didn't do this one in class, but we can still go about it the same way. So criterion 1 says that f of 1 has to be defined. Okay, so when we plug in 1 into this, we're going to end up with 2 times 1 over 1 squared times, 1 squared minus 1. Okay, and so when we simplify that down, we'll end up getting 2 over 0. Now, 2 over 0 basically means that this function is undefined, and we can't have that. We can't have it being undefined. So criterion 1 is not passed, which means that this function is not continuous, and it has infinite discontinuity, because in order to have a 0 on the bottom, that basically means that there's a vertical asymptote there. So this has infinite discontinuity. Okay, this one is one of those special cases. If you plug, it wasn't in there, but if you evaluate it with x equals -6, when you first plug in -6, you end up getting 36 minus 36 over 36 minus 42 plus 6, which is equal to 0. Now, which is equal to 0 over 0. Now, 0 over 0 does not equal 0. 0 over 0 does not make it undefined. What 0 over 0 basically tells you is that there is a hole at -6. And you know this because if you try to factor it and you simplify, you end up canceling out your x plus 6's. And if you plug in -6 to what's remaining, you end up with an actual value. Now, yeah, that means that 1 is defined. And because it's defined, then that also tells you that as the limit as x approaches -6 is 12 over 5. But the issue is that criterion 3 is not passed because originally it was 0 over 0. And 0 over 0 does not equal 12 over 5. In order for criterion 3 to be passed, criterion 1 and criterion 2 have to equal each other. And so basically, to take away from all this is that if you plug in your value and you end up getting 0 over 0, that basically means that there's a hole there. Always, always. Okay? So keep that in mind as you're doing these types of problems. This one here, from here on out, we did like whiteboard practice in class, and so basically students had to determine if it was continuous or not, and this one was continuous because it was the absolute value function, which means that there's no holes, no breaks, no gaps, and at x equals 2, when you plug in, you get 7. So that basically means on the graph, when x is 2, the function is approaching the y value of 7, and criterion 1, criterion 2 equal each other. This one here is a piecewise. As you see, criterion 1, you actually plug in 3 to get 2. Step 2, you plug in you plug in 3 into the left side and the right hand side, and you end up getting the same value, so that's good. And then of course criterion 1 and criterion 3 equal to each other, so this was a continuous function. Another quadratic, remember quadratics look like a U, is continuous, so that means that f of 7 is defined and that y value is 51, which means that as you're approaching 7 from the left hand and the right hand side, it's going to be 51. So all quadratic functions are absolute value functions. Your parent functions, the ones that we talked about, are going to be continuous functions. This one over here, when you try to determine if 4 is defined, when you plug in 4, you get 5 over 0, which means that it's not continuous. So it's discontinuous, and the type of discontinuity is indefinite. Vertical asymptote whenever you have 0 on the denominator. This one here, another piecewise, when you plug in, you see that criterion 1 is passed, criterion 2 is passed, and of course, if they equal the same number, criterion 3 is passed. So this was a continuous function. Then I had them ask, which one is this? Is it continuous or discontinuous? And it is a continuous function, no holes, no breaks, no gaps. This one here is not continuous, and it has jump discontinuity because you have to pick up your pen to get to the next one. Here, this is not continuous. This has infinite discontinuity, hence the vertical asymptote, that dotted line right there. And this one is a hole. It's not a jump because we're still continuing once we go around that hole. Or better yet, it's actually called removable. Hole is like the garden variety word, and removable is the real word for hole. And last but not least, this one, of course, is a continuous function. So if you guys have any difficulty with continuity, you just need to let me know, and we'll just go from there.